of Alexander Skvortsov, Tracy Caldwell-Dyson, and Mikhail Kornienko beginning their journey to the International Space Station.
A Russian Soyuz spacecraft is on its way. It launched from Kazakhstan with, as you heard, one NASA astronaut and two Russian cosmonauts on board, plus apparently a toy duck named Quack. The Soyuz is scheduled to meet up with the International Space Station in a little less than 2 days. Well, you know how they say there is water in space? Well, the technology used to discover underground ice on Mars, for example, could be used apparently to help search for water here on Earth. That's according to NASA scientist Essam Heggy. He says the radar equipment, dubbed MARSIS, could find water beneath the vast deserts of the Middle East and North Africa. And he says it could prevent wars, since water is so valuable and conflicts erupt over resources. Essam Heggy is in Cairo right now, but joins us now via Skype. Thanks so much for talking with us. How would this work?
So it's actually will use the same technology we are actually using right now on Mars, and it's by making a deep subsurface sounding of the water. So if we can do it on Mars, because Mars is a very dry planet, it's a desert, it's the same configuration we have in the desertic area. So 11% of the Earth is a desertic area, and we don't have today any technique to map subsurface water on a global scale. So the only way we have to do that is by using the sounding radar technology, which we tried on Mars for actually two missions. The first is the MARSIS instrument on Mars Express, and the second is the Charade instrument on board the MRO mission.
Well, let me jump in. The satellite, I'm told, is called MARSIS. I believe we have an image of it, but whether we do or not, why is it easier to do this from space at an enormous distance than it would be on the ground just digging a hole?
Because if you dig a hole, you are digging in the local place. So the aquifer, it could be in that place, the subsurface water, it could be 100-meter deep, it could be 50-meter deep. You don't know how deep and the depth distribution of the water. So if you do it from orbit, you are able to cover a huge surface area, which is basically the area of the Sahara and the desert, which is a large area. It's basically as large as 1.2 the size of the United States. So you cannot do, you need some orbital coverage to do a global survey.
And this sounds like science fiction, but I gather it has been successfully done. Where did it get done, and how well did it work?
Well, actually, we tried this technique from 1999 in the desert up to 2006, and this was by two programs, was funded by NASA Mars Fundamental Research Program, and we tried it from the station on the surface. So it was by local mapping in the West Egyptian desert, and the technique was working in very good way. Now we just want to have a mission that will take those instruments in orbital configuration and do this deep subsurface sounding.
Well, let me ask you, if this is such a good idea, and literally water is a life-saving resource, obviously so many people have no access to safe drinking water, why isn't this being done on a massive global scale?
Well, actually, it has not been done on the Earth on a global scale because this technique will work on almost in dry environment and an icy environment. So right now, it will cover a large portion of the Earth, but to make it work in a global way, there is a lot of technical challenges that we have to resolve, and we are yet working on resolving them at NASA Jet Propulsion Lab.
Now, you're talking to us from Alexandria, Egypt. How much would this change the life of the people of Egypt, potentially?
Well, actually, it would change the life of the whole people living in the desert. We have to know that there are 500 million people who live in the desertic area, and these people doesn't have access to find subsurface water, and there is no substantial development program that help develop innovative technique to map subsurface water. So I think the challenge here that we have a leverage from the Mars technology to come to help find water in one of the poorest areas in the world. So for a country as example like Egypt, where its water is in the subsurface, its resources in the other subsurface, its history in the subsurface, the use of such technique will of course help locate new places where we can find subsurface water, and you can make an agriculture in the desert.
Farms in the desert. Essam Heggy of the NASA Jet Propulsion Laboratory. Amazing stuff. Good luck with the work. Time
Thanks.
now to talk about the weather, dry, rainy, and otherwise. Guillermo Arduino joins us now with the weekend forecast. Guillermo?
I have the Asia map behind me, John, and there are a couple of things that I was looking at. In the north, we have some snow, as you see, in northern sections, and in the south, some rain showers. Now, this is new, this is not new.